Hey there, stats enthusiast. Welcome back to our AP Statistics series on Unit 3, Collecting Data. We are going to be going over Notes 3 today, which is all about the bias that is going to be present in studies. So we're going to talk about what it is, how to identify it, and a little bit about how to avoid it as well. So go ahead and get out your notes and get ready to dive into the content. So we've talked about how conducting studies helps us to draw inferences about a population from whatever sample we gather. And we talked about how to gather these samples. So let's say if we take a random sample of our school students and find they work an average of 18 hours per week. Can we infer, can we make the conclusion that the average for the whole school is 18 hours per week? Yes, we can actually. When we take a random sample that represents our population and we find a statistic, we can then apply that statistic to the entire population. Now, the bigger the sample, the better the estimate is going to be. So the larger our sample is, the better the statistic will be at the estimate. Now, this is a fact we'll see when we start talking about sampling distributions. This is a big idea behind sampling distributions that we are going to get into eventually. Now, I'm just trying to put this idea in your head. When we talk about bigger the sample, the better the estimate. If I only randomly selected 2 students, and even if it was truly I randomly selected them, and I found that those 2 students worked an average of 5 hours per week, can we infer that the average for the whole school is 5 hours per week? And hopefully you can kind of intuitively say, no, that seems like too small of a sample. You really have to survey more students or ask more students in order to get a statistic that reflects the population. That's the whole idea behind sampling distributions. And that's what we're doing now in this unit really helps build up to that idea. Your estimate of your population is only as good as your sampling design, meaning that we prefer sampling to a census, obviously for, just cost, time management, all of that. But we have to be aware of bad sampling methods and bad questions that might not accurately reflect the population as a whole. So we want to get a sample that represents the population as a whole, but there are incorrect ways to get that sample and to get that data that are going to lead to results that don't reflect the population. And that's what our notes are going to be on today, is the bias that results. Now, when we talk about bias is producing inaccurate information that is going to somehow systematically favor one outcome over other outcomes. So in other words, when you have bias present, the bias is usually leaning one way. Okay, it's going to systematically favor one type of response or systematically favor one type of person in a population. Okay, we want to make sure we eliminate bias in a study as best as possible. Okay? So here's a few different types of ways bias can be introduced, or types of bias that exist, I guess. First one is coverage bias, by over or under representing portions of the population. So what is one way of over-representing part of the student body at our school would be if our population was all students in the school, but let's say our sample was only freshmen. We would over-represent freshmen. We would get the opinions, let's say, of a freshman, and we'd say, okay, this is the opinion of the freshman, so this must be the opinion of the whole school, right? That's incorrect. You're over-representing the opinion of the freshman. You're not accurately representing the opinion of the entire school. Let's say underrepresenting teachers. What's one way we could underrepresent teachers? Well, if our population was all teachers in our school, but let's say our sample only was math teachers, the other teachers would be underrepresented. We would just have the opinions of the math teachers and then say, hey, that's the opinion of all teachers, when that's not true. We are overrepresenting the opinion of math teachers and underrepresenting the opinion of other teachers. And we want to work hard to eliminate that. We don't want to over or underrepresent portions of our population. Another type of bias might be non-response bias, where people who are chosen to be part of your sample can't be contacted or just don't participate. And non-response bias is another way to introduce systematically overrepresenting certain aspects of opinions, as we'll see. Response bias is when respondents underestimate or exaggerate in some way. So, for example, if you ask what's your exact GPA, or how long should a lunch period be, right? If you think about asking these questions to your peers, your exact GPA, they might not know, they might guess in some way how long a lunch period could be. I mean, you're going to get people or your students saying, forever, the whole day, lunch period should be the whole day, right? They kind of exaggerate their responses. So we have to watch out for response bias. And then the last one is hidden bias, or sometimes called implicit bias, where sometimes unconscious attitudes exist towards someone or something or some subject, and we have to be aware that that could also impact how people respond to our questions. So we don't always know our participants' background to account for their bias. So we have to be aware that sometimes the way we do ask these questions is going to have an impact on the responses we get. So those are the different types of bias. Now let's talk about where we actually get the bias from. One of the ways we get bias is from sampling methods. So we went over all of the correct ways to sample, right? The SRS, stratified, cluster, multi-stage, even systematic has its benefits, but there are incorrect ways to sample. And most of the incorrect ways to sample don't involve random selection. So the two big ones, the first one is a voluntary response sample, where members of a population volunteer to be in the sample. And these types of people are usually individuals with strong pro or anti opinions about whatever it is that are willing to participate. The second type of sampling method is going to be convenience sample. And this is when you sample just people who are easy to reach members of a population. Like if I only sampled my AP Calc students and I used their opinions to represent all math students at our school, that would be a convenience sample. It was easy to reach all of my AP Calc students because they were in my class. Now, what kind of bias does this lead to? If you think about it, it would overrepresent my AP Calc students' attitude and underrepresent all the other math students at our school, right? So a convenience sample, the way I sample, will lead to bias. And in this case, a type of undercoverage, right? I underrepresent all of the other math students at the school. Or let's say Mr. B down the hall samples only freshmen for a survey about home mortgages, right? So when you do that, you are just reaching people who are easy to reach for you, but the opinions that they have are not going to reflect the population at large that you're interested in. The other way we get bias is from the question methods or wording that we have. Poor wording in your questions needs to be avoided. And there's a couple different ways that we can incorporate bias, sometimes without even knowing, right? If we have some sort of a leading question that prompts or encourages a specific type of answer. So for example, if I ask the question, don't you think peanut butter should be banned from all schools for the safety of students with allergens? Right? Now, if you said no, you don't think it should be banned, then that's kind of leading you to, oh, so you don't care about the safety of students, right? So a leading question is supposed to lead you into the type of answer. Or an excellent teacher writes out formal daily lesson plans. Do you write out formal daily lesson plans? Right? If you ask that of a teacher, they're going to feel pressured to say yes because they want to look good in the eyes of the people who are given the survey. Okay, so we want to avoid leading questions, encouraging one answer over the other. Another one is loaded questions, where we have controversial opinions or assumptions and may require a response that is too broad or difficult to precisely nail down. So like, why are women considered better caretakers for children than men? Right? For one, it's kind of an unjustified assumption in that question. And there's going to be a lot of answers that could go with that. Okay. So we want to be careful of loaded questions like that. Or if you say like, what celebrity has no right being a celebrity? Again, the answers are going to be very broad and there's going to be a lot of reasons for those answers. So a loaded question is what we want to avoid in our surveys. Double-barreled questions. These touch on more than one topic, but allow only for one answer. So do you find your first semester of college classes is more demanding and interesting than the classes you took at high school? So there's 2 questions in here, but you're only supposed to respond with one answer. So demanding and interest are 2 different types of questions that have 2 different responses, but the question itself is only looking for one answer. Okay, so double-barreled questions we want to eliminate too. The last thing is choice bias. So limiting or confusing choices in a survey, we want to make sure we are paying close attention to. So for example, if I wanted to know how many high school credits you earned by the end of your junior year, and I gave them a choice and they had to check which one they fell into, what is the problem with these choices I have put on the screen? Well, there's repeated choices, right? If you earned 5 high school credits by the end of your junior year, which box should you choose, right? There's an overlap there that would be confusing to someone responding. Or a limited number, right? What teacher will you come back to visit after graduation? Well, if I only give you 4 choices, there's plenty of teachers in our school, but I only give you 4 choices, that's going to be limiting your choice and potentially invoking bias. Okay. So the techniques of inferential statistics that we're getting into, right? The ability to draw conclusions beyond the data that we see, relies on a good sample. And that sample is only as good as your sampling design. Okay. So things to remember, your sample, it's only an estimate, right? You're going to get varied results from other samples. Whatever statistic you come up with from your sample, it's going to vary from sample to sample. And again, this is an idea that we'll build on in Unit 5 some more. We want to work hard to eliminate bias. We can't eliminate all bias, unfortunately, in some situations, but we work hard to eliminate it as much as we can and identify it when we see it as much as we can. And then the last thing is the bigger the sample, the better. The more people you have in the sample, the better represented your population is going to be. Okay. Our last 2 examples here, we are going to look at a couple different questions. So for this one, on sports journalism, for an upcoming article, a college sports writer hopes to argue that all college coaches believe wooden bats should be mandatory at the D1 level. So we want to identify the sampling method used and then discuss why it could create bias. So I'm going to put up 2 different studies that were used to try and argue this situation. So we're going to identify the sampling method and why it could create bias. So in the first study, the writer of this article attends a college coach's clinic held at a sports venue. He meets them, various levels and sports who attend the clinic, interviewing them about making it mandatory to use wooden bats at the D1 level. What type of sampling method is used and how could it create bias? Well, this writer attends a coach's clinic and interviews coaches from various levels in sports who attend the clinic. So this is actually a convenience sample. He chose people that were convenient to him. And coaches who attend a clinic might have a very specific opinion about mandating wooden bats at the college level. I can't say I know what that opinion is, but they might have a very specific opinion about it. So this convenience sample has left a form of undercoverage bias. We are underrepresenting certain people, we are overrepresenting people with a very strong opinion, maybe one way or the other, about mandating wooden bats. Okay. So for this one, he emails a survey out to all D1 baseball coaches, which would which would be the entire population, but he doesn't receive responses from every coach and just works off of those who are provided. So this is a voluntary response. So strong opinions are most likely to respond quicker and might underrepresent those with sort of mixed or milder opinions here. Okay, the last example. Okay, I have 3 questions here. I want you to identify the questioning method for each prompt. They introduce a form of bias and why it could create bias in the study. Okay, so I have 3 questions. Let's say these were on, this was on a parent survey about the school district finances. Okay, so 1, this was a question: should your school district spend less money on technology and more money on safety personnel? Okay, so what type of questioning method is this? Incorrect questioning method is this. This is a double-barreled question. Okay, it's asking both should they spend less money and asking if they should spend it on personal safety. So if someone had 2 different opinions to each of these, there is going to be bias here. Okay. Second question: like most concerned parents, don't you agree that districts spend too much money on innovative classroom technology? This question method is a leading question. You are leading the people to believe that most parents feel the same way, like most concerned parents, right? So you're leading them to believe that they should agree with this statement like other parents agree with this statement. And then the last one: what key cultural and economic factors of the students at any school should be considered when districts are researching new technology to pursue for their schools? This is a loaded question, right? There's a long and complicated answer to this question, one that can't be answered easily. And for some people, just can't even be answered quickly as well. So for number 3, that's how you're going to introduce bias, is through this loaded question. And that's going to wrap up today's lesson on Notes 3, the bias that is present in studies. If you are ready, you can jump ahead to Notes 4, which is going to be all about experimental design. Thank you guys so much for watching today. If you like this video, please click the like button and subscribe to my YouTube channel for more great AP Statistics content. Until then, I wish you endless statistical success, and I will see you in the next video.